Number 7. Refer to Table 2 on page 210 of the text and Table 5 on page 214 of the text for examples of names and formulas for polyatomic ions and acids. So, as you go through A and B here, have your textbook open to these tables. A. Derive a generalization for determining whether an acid name will end in the suffix ic or us. All right, so in general, when do you end an acid with ic? When do you end an acid with us? In general, if the anion name ends in ate, the corresponding acid name will end in a suffix of ic, of it. So ate becomes ic. ATE becomes IC. In general, if the anion ends in ite, ITE, the corresponding acid name will end in us, an OUS. So ITE becomes OUS. ATE becomes IC. B. Derive a generalization for determining whether an acid name will begin with the prefix hydro or not. In general, if the anion, the name of the anion ends in IDE, the corresponding acid name will end in a suffix of ic and begin with a prefix of hydro. Hydro is never used with anions ending with ate or ite. Now, if we try to compare what I just read to what you've seen in the notes and possibly in the textbook, you might think, hey, that's not how you worded it in the lecture. It's not how you worded it in the notes. You said if it's a polyatomic ion, right, if there's oxygen in the anion, that we don't use hydro. Okay, we don't use hydro. That is true, because realize if it's a polyatomic ion, and if there's oxygen in that polyatomic ion, the ending of that name will not be "ide." Okay, there are no oxyanions that end in IDE. Mostly, IDE is reserved for monatomic anions. Monatomic. So if it's monatomic, that ending is probably going to be IDE. If the anion's name ends in IDE, you throw the prefix hydro in front. If it is not IDE, if the ending is ATE or ITE, you do not use the prefix hydro.